This is a story about how I bombed a technical interview at PagerDuty. Now, if you've been programming for a while, or if you're just getting into it, you'll probably bomb some interviews, and that's totally okay. Typically, the interview process looks like talking to a recruiter first, then maybe an engineering manager's screen, and then you get to the dreaded technical interview. And there's typically two types. There's typically the more like algorithmic, like, here's a little problem to solve. It has nothing to do with what you're going to do in your job, but let's see how good you do. There's also the practical one, like, hey, I know you're used to working with React. Here's something you've probably done every day. Just show me that you've got this knowledge. And this one that I failed falls more on the algorithmic side of things, which is, I think, where I'm the weakest. But that's okay because failing an interview or bombing at an interview gives you an opportunity to learn from that. Both how to be better at interviews, but I think how to improve yourself, and that will help you later on in your career. So you can sort of look at it as, hey, it gets you down, it sort of bums you out, probably will for a little bit, but it can also then motivate you for your next one. Now, going into a technical interview, it's a good thing to research and practice if you're able to. If you're applying to one of those bigger companies like Google or Microsoft or Facebook, there's books written about it. There's a lot of articles and research done of here's how they do technical interviews at those companies. Smaller companies won't always have this, but you can even just ask the recruiter you're working with, hey, what's the technical interview going to look like? Is there anything I should prepare for? What do I need to know ahead of time? And at the end of the day, you may fail an interview, and maybe that's a good thing. I think it was in this case, not because PagerDuty wouldn't be a good place to work. I use PagerDuty where I work right now. It's a great product. But maybe if they wanted a developer who knew how to do the sort of thing well that they were asking me, maybe it wasn't a good fit, and maybe it wouldn't have been a job that I would have enjoyed. So anyways, why don't we look at what they asked me to do? And it's easy now that I haven't been thinking about this for 8 years, but I've had time to sort of learn through these mistakes and get better at it. But what they wanted me to do is, given a set of numbers, so like let's say an array of numbers, 100 numbers, find all of the pairs that add up to 100. So we're going to get into the code now, and we're going to look at sort of where I got to as I stumbled and bumbled through this interview, and then maybe what would have perhaps gotten me the job. I don't know, but we'll look at and we'll time each solution to see how we can improve. And in the process, we'll learn some things about how to speed up our code, different data types and data structures, and ways to find numbers or any sort of piece of data in an array. So looking at the code right now, I've got a function called time. This will just sort of spit out how long it takes to do each solution. And then I've got an array of numbers. So I'm going to start with 100, and then later we'll expand that because with bigger numbers, we'll be able to see the inefficiencies of each of the different solutions. So if I run this code, we'll just say node index. Here are the numbers we're looking at. And then here are the different solutions we're going to go through. Right now they don't do anything, so they all take around the same time, just like 0.02 milliseconds. So pretty snappy when you do nothing. That's sort of the key though. You want to do as little as possible to find the solution. And that's basically as we go from this most naive one to potentially the fastest ones. You're trying to limit the number of work you do, which often comes down to iterating less times. So here's what we're trying to do. Take this array of numbers, and say if we're on number 1, we want to find the pair that adds up to 100. So 99 would be that pair. 1 plus 99 is 100. So for at 5, we would be looking for 95. That's the pair that adds up to 100. You have to be careful because 95 plus 5 also adds up to 100. But we just want sort of the unique pairs. So we don't want to include that twice, just one time. So let's do it the naive way first. So what we're going to do is we're going to iterate through the numbers. So for each num. And we've got a num, so we know, like, say this is the number 1. So now we want to look through the numbers again and try to find the one that adds up to 100. So what we can do is a second loop. That's our first mistake. We've got a loop and a loop, which basically you multiply them together. That's how many times you're going to iterate over it. So what we're going to do is we're going to use find, and find sort of finds the match out of an array. So we'll say n because we can't use num again. So we want to find where num plus n is equal to 100. But remember, we've got that problem of each pair showing up twice. So we can just say and num is less than n. So we want the first one to match. We don't want the second one to match. So we'll put that in a variable here. And we'll say if there's a match, this returns undefined if it couldn't find the match. What we want to do is pairs, push the pair, so the number plus the match. That's the pair. So if we get to the end and we console.log the pairs, what we're going to get is it took 1.88 milliseconds, and here's all of the matching pairs. So 1 plus 99, 49 plus 51. So we can run it again. It's going to vary a little bit each time, but that's okay because it will give us a pretty good idea. So I'm going to get rid of this. You'll see it actually speeds up. A big part of the speed is that console.log, funny enough. But we don't really see it until we get to bigger numbers. So let's go all the way to 10,000, and we'll be finding in this case pairs that add up to 10,000. So 1 plus 9999, etc. And instead of having to hard code this number each time, we will just say total equals 10,000. So we can say total and total here. So if we run this again, we are now seeing 293 milliseconds, half a second almost. So it varies, as I said, but you can see it's getting pretty slow. Let's stop logging out the numbers. And to avoid having to run this manually each time, we'll just use nodemon to keep an eye on any change that happens to this file. So it will just automatically run. Okay, so the problem with this is we're iterating 10,000 times, and for each of those we're iterating another, potentially in worst case scenario, 10,000 times. That's a lot of loops. I don't even know how many zeros that is. So we want to try to limit that. So one way we can limit that is basically, let's split it into two halves. Sort of the first half is under 5,000, second half is above 5,000. So what we'll do is we'll call this under. So we'll take the numbers and we will filter them out where the num is less than basically the half. So we'll put that into a variable here. Const half is equal to total divided by 2. Cool. So if that's under half, we'll now do above half. So now we'll say filter num where num is over half, just like that. And now we can do the same sort of naive solution, but we're going to iterate only through the numbers under half. And in this inner loop, which is actually the most important one, we're going to only look through the ones above half. So right there, we basically cut the number of iterations in half, and you can see that the time went down a ton. So we started at like almost half a second, now we're down to 160 milliseconds. So I thought it would only sort of go to half, but we actually sped it up more than half. This is about where I got to in this interview in the allotted time, which was, I don't know, maybe half an hour. Now, I don't know why I was bumbling a lot. This was actually in Ruby, not in JavaScript. But there's something awkward about it's called a pairing interview, like a technical pairing. There's someone beside you and they're like, hey, I'm not judging you. I'm here to work through it with you. really the only thing they're pairing on is like your suffering as you like fail and mess up things that you would never mess up on a day-to-day basis. So part of it is just starting to get comfortable with that interview process. It'll never feel great, so you just sort of do your best. Now, if we want to come up with a better solution, we need to find a way to basically speed this up so that for each number, we're not iterating 5,000 times. So instead of find, we can try using the built-in includes approach. So I'm going to paste this again. All of this. Actually, why don't we type it out? So let's get these set up like that. So we're going to go over each of the numbers under half. And what we want to do is basically find out if the pair or the number that would add up to 100, or in this case 10,000, is in the array, this above array. So one trick you can do, first of all, we're going to be using includes. So we're going to say if above includes. So how do we find out if the pair is in there? Well, if you know the total, let's say 100, and you know you have, I don't know, the number 10, then what you want to find is 90. So what we can say is if the above includes 100 minus 10 is 90. So that is the other pair that would add up to the total number. So if we do that, we can then push that match, so num and then its total minus num, which is the other half of it, onto the array. So it runs through, and this is a huge improvement. So we went from 489 to 172. We're down to 18 milliseconds to find all of the pairs. And this basically just shows that includes is a lot more efficient than find. But includes doesn't take a function that allows you to do logic and stuff like this. It only works if you basically have the exact element you're trying to find. In our case, we can use this sort of trick here, and I did not know this trick. This is sort of why I gave up at this point in the interview. I didn't know how to improve it any further. I'd sorted the array, I had like cut it in half, I'd filtered it, I'd got it to this point in like bumbling about, but I never got it past then. So at this point, like, can we improve this anymore? And we have to switch to a different data structure. So up until this point, we've been working with arrays, and there's basically in this case a more efficient data set we can use called a set. So we are going to copy and paste this because it's almost the same. And a set is basically a unique array. So you can just keep putting elements in this array, but if it ever finds a duplicate, it won't add it because it's already there. So the way it sort of deals with that internally, it allows for more efficient lookups if you know the element that you're trying to find. So what we can do is we can take this above, and instead of it being an array, what we could just do is make a set from this. So same basic thing, you pass in this array of half. Now we have a set instead of an array. And a set, instead of includes, you use has. Does the set have, or does it has this element? So we run it again, and this time we've gone from 17 milliseconds down to 4 milliseconds. So we've gone, what is this? We've made a 100x improvement on our code so far, with very few changes, just trying to do less work, and now we're getting into using more efficient data structures. So if the key to speed is basically make this lookup as quick as it possibly can, one approach you could do, and we'll see if it's better than the set, is to use an object. Looking up a key in an object is extremely efficient. So if we can have all of the numbers that we're going to look up as the keys in our object, maybe we can make this more efficient. So imagine you've got an object like this, and you've got like 1 true, 2 true, 3 true. It doesn't like this because you can't have numbers. So imagine these were strings. Now it's happy, I think. Whatever, you get it. We want to basically do an object like this so that we can just look up the key, and true, because it just to have a value and to check if it exists in this object will give it true. So we basically want to create an object like this. So for that, what we can do is we want our array of anything under, and our above we will take our starting point, and we're basically going to map, so num, and it returns num and true. Why would we do this? Because now we've ended up with like an array of like 1 true, 2 true, etc. And if you have a data structure that looks like that, you can do object.fromEntries, and it will convert it into the type of data that I was showing above. So if we basically just want to do this thing again, but we're going to loop through all of the numbers under half, and we want to check if there's like a corresponding pair in here, but we wouldn't use has. We would just look it up like an object. So we would just check saying 100 minus 10, so look to see if 90 is in this object. So if we do this, we get basically the same performance as a set. It's slightly worse. And I think I noticed that if I go to 2000 total, no, it's even worse here. Basically, I think what's taking the long time is this like converting it into an object. Like if we were to just do that ahead of time, it's faster than a set. So the thing that's slower is this like conversion into an object. So one way we can try to improve this is, well, we don't have to do this filter first. So why don't we move this back in? We don't have to filter first. We could just sort of do all of them. See if that helps. That gets rid of one loop. Now we're down, like we're slightly under, like less than 1 millisecond better. But there is a better way that I've found out. And it's basically, we're still doing 2 loops here. We're doing like 1 loop to map them all into this like array of arrays. And then whatever from entries does, I think does another iteration to convert it into an object. So if we sort of just do that work ourselves using reduce, so we'll say numbers.reduce, and we get the accumulator and the number, and our starting is an empty object. What we want to do is take the accumulating object, put the num in and set its value to true, and then return the accumulator. So if we do this, we've now got it down to half of a set. So we've gone from, let me put this down to 10,000. Cool. It's basically the same at this point. So I guess 20,000 is where it starts to get better. We've gone from 1 second to half a second basically, to 64 milliseconds, to 5 milliseconds, to 3 milliseconds, to find the pairs that add up, in this case now to 20,000. And we did it pretty quickly. But it took us a while to get here, and it's part about knowing where can I get the efficiencies in this algorithm, how can I iterate less times, or how can I use a more efficient data structure that allows for quicker lookups. Part of it is knowing the data that you're working with though. Like if we change this back to 100, yes, it gets slightly faster, and actually set includes is the best at this point. If you're working with really small data, you really don't need to worry about this sort of efficiency. Like the most naive solution is half of a millisecond. So don't try to optimize where you don't get any value from the optimization. And there's different sort of points where some solutions may be better than other solutions. Like object started to shine when we got up to 20,000. And I'm sure if we got up to like 30, 40, 50,000, it would start to shine even more. But if you're working with numbers that are smaller than that, there's no point because this solution had more like setup cost than some of the other ones. We could potentially even, if we just didn't do the initial map, now we actually, let's see. Okay, so we'll try this a couple times. Object is like slightly faster to the point where it doesn't even matter. So in that case, I would optimize for the cleaner code, the code that's easier to read for the next developer looking at this, than the one that's like very slightly of a millisecond faster than the previous one. Because this one's harder to read, we've got a reduce going on, and why are we switching to an object? It's a little bit confusing. So you're trying to optimize both for speed and efficiency, but also, and probably more importantly, who's the developer who's going to be looking at this code next? Let's make it really easy to read for them. Anyways, this was the story of me bombing this technical interview, the question that I bombed on, where I got to during the interview, and a more efficient solution to come up with something that performs about 100x faster than the most naive solution. I would love to hear about, well, not that this will bring me joy, but feel free to tell me about the times that you've bombed interviews, what the question was that they asked you, and did you look after and try to figure out what the solution was? Leave a comment. I'll talk to you soon. Bye.